This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Thank you for joining us for the 6th edition of the Satellite Book Club Seminar Series. Hope everybody is staying well. Just a few reminders before we get started on today's presentation about Alaska ice breakup and satellite detection of that flooding with VIIRS. First of all, this session is being recorded, and if you have a colleague that is missing this due to shift work, we will have that posted and available for folks to watch online. There will be a Q&A after the 15-minute presentation. Please feel free to type your question into the chat box to everyone if you'd like during the presentation, and that way we can prioritize which questions are addressed. And if there's anybody out there who's interested in presenting in this form, the Satellite Book Club, we'd love to have you, and especially looking for folks with new satellite applications in the field. As always, we want to tailor this to your needs, so we will have a feedback survey. Appreciate your help in filling that out and letting us know if we're providing something that's useful to you. We have a Tower S team that's able to help you with data access and AWIPS configurations. Lee Byerly and David Blutis are joining us today, helping with the teleconference. Feel free to reach out to them. Their addresses are there in the NOAA directory. And if you need training materials, we have help from Brian Mata and the rest of the Office of the Chief Learning Officer, Forecast Decision Training Division. A great team of affiliates as well that helps in that regard. So if there's any questions you have about how to use satellite data, feel like the training could be improved, Brian Mott is out there to help you. Just want to thank a number of people, mentioned Lee and David and Brian already, but the GOES-R and JPSS programs have been very supportive of this as well. Dan Lindsay, Matt Siebold, Mitch Goldberg, and Bill Schoberg. With that, I'd like to introduce William Straka from the University of Wisconsin, Cooperative Institute for Meteorological Satellite Studies. He's been there for about 15 years, and he has a number of roles there at CIMSS, including a real passion for the day-night band on VIIRS. But today he's going to be talking about the VIIRS flood detection assistance in the Alaska ice breakup. And he's interacted with forecasters and other stakeholders, including FEMA, on utilizing flood and other satellite products for disaster monitoring and response. So with that, William, welcome to the Satellite Book Club. Look forward to what you have to present today.
Thanks, Jordan. Good hearing you again after the, we interacted while you were out here at CIMSS as well. So yeah, I will be talking about VIIRS flood detection and assistance in the Alaska breakup, and I think maybe later on we'll be able to get Jessica Cherry from the River Forecast office up there at the Alaska Pacific office there to maybe chime in at the end if possible. I always say I couldn't do this slide deck by myself. I had a lot of assistance from Jesse as well as Carl Durking up at Gina, so of course I have to acknowledge JPSS, Mitch and Bill, as well as Sam A. Lee, who's the developer of the flood products, and Jay Hoffman, who helps out on the technical side in producing and running the algorithms. So. Just a quick background. I'll give a quick background of the situation of the products and what the Alaska River Watch is. A little bit of overview of the VIIRS Flood product for people that may or may not be familiar with it, and then go into a bit of a discussion of the 2020 season, which was unique in and of itself, as I think we all know. Given the current situation of 2020. And then also just briefly touch on some other products, up-and-coming products, and a little bit of a summary of the season and the presentation. So, so a little bit of a background of what we're talking about up in Alaska. I think people are very familiar up there. Probably seen some of these shows that are up there. During the winter months, the rivers are freeze solid, and in some locations, you can drive semi trucks over them to transport equipment up and supplies to the various camps. But then in the spring, as the temperatures warm and the river ice melts, obviously it will break into pieces, and that can potentially cause ice jams, which can then in turn cause flooding to river communities. For example, the image in the upper left is actually from McMurray, Canada, this year, which actually had a pretty significant river ice jam that ended up flooding a lot of the downtown area in Fort McMurray. In addition, the ice flows can transport damaged boats and barges and other equipment along the shoreline as well. Cause erosion along the shoreline, which of course can impact infrastructure as well. So, just a brief background on the components of Breakup, and I hope that I will do it justice here. Obviously, a lot of this is borrowed from the Alaska Region National Weather Service. So essentially, the components of an ice breakup include the size and the thickness of the ice, how much snowpack you get, and then, of course, what is the spring weather pattern? The temperatures in April and early May, that'll control some of the snowmelt rates, thermal conditions, and the integrity of the ice. And then the type of the breakup. Is it a dynamic and a thermal or a thermal? And I'll briefly touch on that as well here in a little bit. So going a little bit of background, what Riverwatch is. It was generally executed as basically a reconnaissance flights using charter aircraft from the state of Alaska Emergency Management Agency, as well as the Alaska Pacific River Forecast Center, and Civil Air Patrol. And it's a decades-long partnership, but National Weather Service is moving towards these impact-based decision support systems, and one of the aspects of that up in Alaska is that they are working directly with the community to get reports along the river, as well as other partners such as the various JPSS initiatives and other initiatives that are around to get the needed information about the river conditions. Basically, the goal is to provide real-time monitoring and timely alerts to keep the Alaska community safe during the breakup and provide accurate forecasts. On the right, they have river notes. This is some part of that where they get information from people in the community, and so they have basically information about what's going on in the community from various sources. And of course, in Alaska, a lot of the people are in remote regions, so you don't have easy access to people the ability to respond easy to various incidents like a flood. It's a brief overview of the flood product. Interestingly enough, the idea came about back in 2013 with an ice jam up in Galena, Alaska, which flooded the entire town. Basically forced all the residents to be evacuated. And I think if I recall the story correctly, I've heard it from Mitch and Bill a number of times, that it was at a CSPP meeting, and the idea was how can we assist and monitor, because we have the VIIRS instrument on CIMMS as well as now NOAA 20, to provide this sort of information in these remote regions. Since then, it's expanded to not just VIIRS, but also ABI and AHI, as well as a joint product between the ABI and AHI products. And basically it provides to provide flood aerial extent, and it can be used for situational awareness. Obviously, since it is optical, it requires clear sky conditions and is only during the daytime. And well, you want to use the highest resolution product, namely the VIIRS product, as it's recommended because it gives a more accurate detail of where the floodwaters are. And well, this is not necessarily related to Alaska. The ABI and the HI ones use a cloud compositing process that basically filters out the clouds that can provide basically a clearest region, and then you apply the VIIRS passes on top of that to provide the high resolution data. This is just a list of the products, so I won't go into too much detail, but you can see there are over half a dozen products that are available. Both some of them are global, some of them are from the direct broadcast antennas, which of course provide more timely information. So just a little bit about the direct broadcast product. It's actually the same product as the near real-time processing system, but it utilizes the direct broadcast antennas, both up in Alaska, up at Galena, and then also down here in the continental United States at the University of Wisconsin. About a 20-minute latency, maybe an hour, depends on how you're accessing the data. So if you're accessing it through AWIPS or pulling it through an FTP server, it can be slightly longer. The FTP server can be slightly longer sometimes. The data is distributed via AWIPS as well as through GeoTIFFs for display in Real Earth and other GIS tools. Those can be, you can utilize, if you're using Real Earth, you can actually use Web Tile Service to integrate it into your particular GIS tool. Given the Arctic, you have many more passes than you do at lower altitudes. Normally you only have two passes over a given region during the daytime, whereas Alaska you get well more than that. And of course, depending on the orbit of the pass, your pass might encompass the entire state of Alaska, which is the largest state in the United States. So it is quite the useful tool up in Alaska, where you don't have that geostationary capability. So why was 2020 so different than, we'll call it a normal year? Well, Alaska had a cold, call it traditional winter, but they also had an abnormally large snowfall. As you can see, this is the snowfall equivalent over the eastern part of Alaska. I pulled that from the Alaska Weather the National Weather Service up in Alaska to show the snowwater equivalent. This suggested actually to the River Forecast Center up there that 2020 could potentially be a bad year with a more dynamic breakup. And then there was the obvious elephant in the room, namely in March timeframe, there were stay-at-home orders that were issued across the entire United States, including Alaska, which they could have impacted the River Watch charter flights because you're limited on you have to stay at home, you have to be socially distanced and the like. So there's there was a lot of potential that could have been in there for potential impacts that could have been there. So we're talking about the types of breakups. What was the dynamic versus the thermal? Basically, the dynamic, your ice is hard, it's resistant to breaking up, and then when you push downstream, you get a dam, and you get upstream flooding. One of the extreme cases, of course, was the Yukon in 2013. The thermal is sort of some comes rotten, it's weak, and you don't get into these small pieces, so you don't really get the ice jams. And this is again their forecast in early April from the National Weather Service up in Alaska. And now, as I mentioned, most breakups are a blend of the two; they're not one or the other. But back in early April, they were saying it was trending towards 2020 was trending towards a more dynamic breakup. So, fortunately, there was the ability to have some River Watch flights during the seasons, and it was primarily with the National Weather Service employees like Crane Johnson and others. And then, in addition, there was additional help with the Civil Air Patrol being able to fly over, and the assistance of the community reports and we helped augment some of the observations for them during the time period as well. While there really wasn't a lot of bad ice jams like you saw in Fort McMurray in Alaska, there were a few areas that were impacted, but fortunately the weather cooperated. The headwaters of the things cooled, so you didn't have as much water going downstream, and it warmed up in lower elevations, so the snow melted off earlier in the lower elevations before the higher elevations before they melted. So I'm going to go through just a few examples here. This is an ice jam that was reported by a ground-based observer in Sleetmoot back in late April, which on the left you can kind of see the overall situation, and on the right you see a zoomed-in one. The main point there was that they were noticing that the ground-based observation was saying the main channel, the rightmost channel, was covered in ice, while as the secondary channel, which is a smaller channel, was open. And this, of course, did cause some flooding upstream, which you can see towards the bottom of the zoomed-in image there. Mentioned there were river wash flights. Now, the river wash flights also provide a good place for validation of these algorithms in remote places, because normally you don't have people going out making observations on a routine basis, so you kind of need a way of validating the algorithm. And so Crane Johnson was looking down at the Yukon. This is in early May, looking just basically right near Circle, Alaska. And you can kind of see that it's not exactly the same time, but the same features appear. The rightmost channel had ice in it, and the leftmost channels were fairly open, and you can see that in the observations there. I mentioned I'm going to go bad on I'm not going to be able to pronounce it. I think it's Kelowitha, is Alaska. This is at one of the places that actually did have flooding. And as you can see, you had an aerial observation. You can see flood inundation into the community itself, and the VIIRS products were showing that yes, indeed, you were getting not just the moistening of the wetlands there, but you actually were getting flooding inundating the village itself. They have some FAA cameras at some of the airports there, which also provide some very good comparisons that allow us to do some qualitative evaluations. This is up in Kena. I'm not going to try to pronounce the name. Sorry, one of the villages up there, and again, you're able to look off to in this case, the eastmost camera, and look at what the river was doing in the VIIRS product at nearly the exact same time. In this case, it was just a couple minutes off, so we were able to get near temporal comparisons there, and be able to say, yeah, you can easily see that you're getting moistened areas there, as well as some ice along the banks as well. I mentioned other useful derived products for flooding and ice detection. One of the other ones that we did use that had some issues, but the team is working on it, is the VIIRS ice product. This can help this is actually a better algorithm to help discriminate where the river ice is located. It's produced over the continental United States and Alaska at their respective broadcast sites, and it's the same code that was developed by CCNY. Both of them, of course, are available in real Earth. I mentioned the CMORPH 2 accumulated precipitation product here because, as you go from the winter season to the rainy season, there are areas, particularly in Alaska, where you don't have a lot of radars, and so having the ability to look at accumulated precipitation in those remote areas it could be potentially very useful. GENA has been producing the METEORS rain rate product in Alaska for some time, which has been provided for integration and running in the CMORPH algorithm. And they're now producing and displaying in real Earth the global 1 hour, the hourly, daily, and weekly accumulated precipitation products. The image on the bottom there is actually an image from Cristobal just a few weeks ago over El Salvador and the Mexican Yucatan. There are also other products in Alaska that are unique. You can get the Sentinel-2 imagery. It's again it's an optical imager from the Alaska Satellite Facility. Samuel Lee at GMU is developing a downscaled 30-meter VIIRS flood extent and depth product. It's currently under development, and it's currently going to be. It will first be over the continental United States. There's a link there to a news article that discusses this in the case of the Michigan dam failure. And the last two, I think were kind of a little more exciting. Sean Carter at the National Water Center developed a SAR, a synthetic aperture radar ice detection algorithm that was demonstrated in Alaska during the breakup season. And I know there's been some discussion about that product and how it could go into operation and the like. And the final one is there's a SAR blended flood inundation product that the project has just started and is under development. So that's something to look for in the future as well. Just to briefly touch on the SAR data, this is again that sleep moot case. The main thing is VIIRS provides the 375 meter resolution, but as you can see in the image on the bottom, the SAR product provides a much higher resolution of where the ice is and can detect finer features particularly along on the various channels there. And as I mentioned, it was demonstrated in the 2020 breakup season this year. And then just a quick summary, basically, of what I said. 2020 presented, suggested it was going to be bad, and there were some potential impacts with the stay-at-home orders. While it didn't happen, as the National Weather Service is moving towards this impact-based decision support system, the Alaska Pacific River Forecast Center is now working with the community as well as other partners and the JPSS initiatives to get that needed information on river conditions in remote areas. And of course, partnerships that we have with the National Weather Service, particularly up in Alaska, is not just critical for just demonstrating the products, but it's also critical for helping provide ground truth verification. Well, I should say air truth because it's from the air, but there were some images from the ground as well to help provide the verification and validation of the algorithms that are being produced. So I just have a list of contacts and acknowledgments there if there's any questions to refer people to. With that, thanks.
Thanks, William. That was great. At this time, before we open up the questions, and with that, I would encourage you if you do have a question for William, to please type that in the chat room and we can field it through there. Or if you'd like to ask a question verbally, you can indicate that as well and we will unmute you there. But before we do that, we would like to invite William's colleague, Jessica Cherry, a hydrologist with the Alaska River Forecast Center. She'd like to weigh in here, add anything to the discussion. I think we do have you unmuted, Jessica, if you'd like to say a few words.
Sure, yeah, thanks. And thanks, William, for all that review. I don't have too much to add. There were some impactful situations and of course, very anxious communities in some of these places where temporary ice jams did form on the Kuskokwim in particular, and there were rising waters and inundation of a few homes and an elderly couple that was rescued by helicopter from a boat they tied to the roof of their cabin. So there were some impacts, and I think for everyone in Alaska, this was a very anxious time, just for all of the reasons that William described. But we reached out to this community and got this incredible support from William, who was reviewing these products and sending us updates a couple times a day. It just was so helpful to have other eyes on Breakup. We were pretty short-staffed as well this year, and of course the investment that this program has made over the years in these products is really paying off for us, I think, as a major user. And it was just really fulfilling to talk to folks in some of these communities. I did not deploy on the Riverwatch flights, but I was the hydrologist in charge for the start of the flooding on the Kuskokwim, and just talking to a teacher, at 10 o'clock at night, who's frightened, and the waters are coming up over the road, and being able to say, well, at some point I even showed her one of these satellite images. She was someone who teaches science and was interested in what we could see from the satellite, and I think there was just a lot of comfort for people knowing that we, even from our homes and offices, had the ability to look out for these communities. So I think this program is really paying off, and I look forward to further development, combining some of the SAR products and some of these downscaling techniques are really exciting. And yeah, I think this is a real success story for the program.
Thank you, Jessica. So we do have one question here. What gaps are there in remote sensing for ice jam flooding?
Well, from my point of view, there's certainly challenges with cloud cover, and that's where the potential of multi-sensor products with SAR, which can more or less see through the clouds, I think would be helpful. I think we had a sort of a hot wash discussion on Breakup yesterday on our staff, and one of the things that came up, there were events in midwinter, sort of December, January, where the parts of the Kuskokwim River broke up and then refroze, and that process added to the strength of the ice and the thickness. And one of the questions would be, could we develop a product that told us more about midwinter breakups and ice thickness and roughness? The Alaska Satellite Facility up at the university has looked at ice science for many, many years. The rivers have not had as much attention, I think, as some of the lakes in Alaska, but there has been quite a bit of science in northern Canada on looking at properties of rivers, of frozen rivers, specifically from, I think, C-band SAR, and so there's, I think, an opportunity for translation of research and international science into some of the problems we are seeing in Alaska. And again, for these multi-sensor approaches where the frequency we have of the VIIRS coverage is just incredible, and we want to be able to leverage that with some of the sensors that can see through partially through the ice, or even with a modeling effort, say, on ice growth on the rivers. So lots of opportunities, I think, for filling gaps with research and new operations.
Okay, great, thank you. Jordan, I'll turn it back over to you.
Okay, thank you, David, and also thank you to Jessica Cherry and particularly William. my good old colleague at Wisconsin, for that wonderful presentation. We'll have to leave it there. I know there might be a couple more comments coming in from Brian, but I'll have to take those offline since we are at the 30-minute mark here. I just want to remind everybody that next week, another one of my colleagues from CIMSS, Chris Schmidt, is going to be talking about fire detection and characterization with the ABI and some of the enhancements. So look for an email from that coming up from the TowerS team. And with that, just want to remind everybody once again that this has been recorded, and you can refer your colleagues to that link once it's available. Thanks everybody for attending. Hope you're staying well, and have a good weekend whenever that comes for you. Take care now. Bye.
Thank you.